Today's lesson is on the ideal gas law, and as you could tell here, we have a little visitor this back, the mole. So let's take a look at the ideal gas law and what it allows us to calculate. The ideal gas law allows us to calculate the number of moles of a contained gas, and it requires an expression that contains the variable N. So you're going to see N, and in this gas law, N stands for the number of moles of the substance. Now remember, N is our SI unit for our amount of our chemical substances. This gas law only has one pressure, one volume, one temperature in it. R is our constant, and N stands for moles of our substance. This is different from what you would see with the combined gas law or Boyle's, Charles's, and Gay-Lussac's law, and that those gas laws have two pressures, two volumes, and two temperatures in them. Here we are holding the pressure, volume, and temperature constant, but we have the variable moles here. In this gas law, it is very specific to every unit. The first unit that I want to talk about is that of pressure. Your unit for this gas law for pressure must be in atmospheres. For volume, you must make sure that the volume is expressed in liters when you plug it into the formula. N stands for moles of your gas. So if they give you the grams of the gas, you'll have to convert it to moles first and then plug in the moles. N stands for the number of moles of a gas. Temperature still has to be in Kelvin. Every gas law has to have the temperature converted to Kelvin. The ideal gas law is specific to each of these units, and the reason is because of R. R is our constant. It's known as the ideal gas law constant, and there are several variations of this constant with different units. The one that we're going to use is the one that has units of liter atmospheres per Kelvin mole. So this is the one you'll want to memorize, the value for 0.08206. Always double check your units and make sure they're in agreement. Notice here in this unit there are 4 different units involved, and they have to cancel, and that's why we have to have units agree. Liters here cancels with the liters in the volume. Atmospheres for pressure, because atmospheres needs to cancel in the unit for R. Temperatures in Kelvin, so that Kelvin will cancel. And then of course N is moles, and so we have moles here. Now, the ideal gas law, it can be used to calculate pressure, volume, and temperature, but it can also be used to calculate the number of moles of a gas present. So if you're asked to find the number of moles of the gas present, you just simply solve for N, and remember N is moles. Now we have, over our study of chemistry, we've learned how to convert from moles to other units. So we will be doing that in this particular unit as well. So let's say that they, instead of wanting you just to find moles, they want you to find the molecular weight of an unknown gas. Keep in mind, molecular weight has units of grams per mole. So your plan, in the event that they ask you to find the molecular weight of a gas, is you're going to solve for N using Pivnert. And once you get your N, your moles, you're going to then divide the given mass, which would have to be given to you in the problem. They will have to give you the mass of this unknown gas. So take the grams and divide it by N, the moles that you just solved for. Another thing that you might be asked to solve for with the ideal gas law is to find the mass of the gas produced. Well, the unit of mass is grams. So if you're asked to find the mass of the gas, solve for N, and then you'll have the moles. Remember, N is moles. And then you're going to do a one-step dimensional analysis problem. You're going to multiply by the molar mass of your gas, and that will give you the grams of the gas. Another thing that you might be asked to calculate using the ideal gas law is they might want you to find the number of molecules of the gas present in the sample. So if they ask you for the molecules, remember you need Avogadro's number when you're trying to go to your representative particles. So you'll solve for N with Pivnert, and then of course use a dimensional analysis problem to convert using Avogadro's number, 6 times 10 to the 23rd. This is part 1 of our ideal gas law video, the introduction to the ideal gas law. In the next video, part 2, I'm going to be working through some problems with you that are in your notes pack.